Hello, and again, welcome to the Aperture Science Computer Repair course training video. We hope your brief detention in the Aperture Science Computer Repair Vault will be a pleasant one. I am your host, GLaDOS. Let's continue to the expert in the field of computer repair, Dr. Kleiner. Dr. Kleiner, take it away.
Hello everyone and welcome! I am Dr. Kleiner, and I see that you are computer repair students. Now that we have that figured out, let us begin Chapter 6, Supporting Processors. There are three main parts to a processor: the input-output, or I/O, the arithmetic and logic units, or ALUs, and the memory caches. The input-output circuits regulate basic input and output. For example, if you pressed a button on the keyboard, the I/O would see that as input. Then it would generate as output on the computer screen. The arithmetic and logic units allow the computer to process mathematical problems and allow the computer to process logical conclusions, such as 1 plus 1 equals 2. The memory cache is a special memory module for the CPU. It is much faster than RAM, and it could hold a lot more memory. However, it is temporary. If you come this way, I'll show you more examples of how CPU works and how you can modify them. Here, we can learn about overclocking, throttling, and multi-processing motherboards. So please take a look at the screen. Here we will demonstrate how overclocking is dangerous. Let the Stargate represent the processor we are overclocking. Now remember, students, overclocking is very dangerous. Don't do it unless you know exactly what you're doing. So, just pull some wires, stop some stuff, plug wire in, twist this knob, eat a sandwich, change the bus rate, activate system 32, deactivate my wife's nagging, and there we are! That's easier than 3.1415926535859. Just a reminder, never overclock any of your computer components unless you know exactly what you are doing. Now all we need to do is turn on the processor/Stargate to see if it works. That's not good. I'm sure it will stop soon enough. I think I did something wrong. Now it's not stopping. I did do something wrong. Yes, I made a mistake there, but everyone's human. In the next clip, let the ship represent how throttling is good for your computer.
Lieutenant, warp speed engaged.
Aye, Captain. Captain, our core is at risk of being damaged.
What's wrong, Commander?
The core is drawing too much power needed, and it is overheating. I recommend we throttle back and drop out of warp before the core is damaged.
Thanks, Commander. Lieutenant, drop us out of warp.
Yes, sir.
Captain, it's working. Our Intel Core 2 processor is cooling off. No damage is sustained.
Good job, Commander. You will be promoted.
Yes, you all understand now, right? In the next few minutes, I will show you what multi-core processing is. Multiprocessing is like having 2, or 3, or 4 processors in one housing. Hold on a minute. Yahoo! Okay, here we are. Now take this car for example. Dull, boring, slow. Now, adding another processor to a computer is like adding a rocket onto this car. Ready, set, go! There are several ways to increase the speed of the processor, and they are multiprocessing, multiple processors, and multi-core processing. Multiprocessing is when a processor contains more than one ALU. With 2 ALUs, the CPU can process 2 instructions at once. Multiprocessors are when a motherboard has more than one slot for a CPU. It is capable of running more than one processor at a time. However, only specifically modified motherboards can do this. Multi-core processing is when there is more than one core inside the processor housing. They work at the same frequency, but independently from each other. Also, each core has 2 ALUs. So, if a CPU had 3 cores, it would be able to calculate 6 instructions at once. And if it had 4 cores, then it would be able to calculate 8 instructions at once, and so on and so forth. Each core within a processor has its own independent internal L1 and L2 caches. L1 is on the die, while L2 is off the die. Yet, they all might share one L3 cache. That about sums it up. Thank you so much for watching, but now we are out of time. I return the floor to you, GLaDOS.
We thank you for watching this Aperture Science computer repair video about supporting processors. We hope this has been a learning experience, and an enjoyable one.
Goodbye.